Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today, with most of my screencasts, I'll be discussing the reciprocal system, specifically the reciprocal system Macrocosmos database. In previous screencasts, I've covered everything you see here on the left side here, astronomical properties, the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and clouds, events and voids. I've also covered the general progression and gravitation graphs. So now we're going to look at star graphs today. So let's click on that. And we're going to go with the sun, which is the most important star, of course, for us. And let me just show you what the choices are. So for the abscissa, you can have R mean over R. So that means it's starting from the center, basically. And the ordinate, and of course you can also have atomic number. We'll get to that in a moment. And for the ordinate, we can have density in grams per cubic centimeter, pressure in atmospheres, temperature in Kelvin, volume of shell divided by total volume, and mass of shell divided by total mass. So what I've done here is use a linear density model, so you can see it's densest at the center, and then it just linearly goes down to the near the surface. Okay, so let's try something else here. Let's go. We'll keep R mean over R. Let's try pressure this time. So then we click here for generate the graph data. You got to pause. There it goes. It's working. And by the way, the graph data is stored here, so you can copy this out if you need to and put it into a different program, but I doubt that you would do that. And then you click here, generate the graph. So here's the pressure. So obviously it's highest pressure in the center. Look at that, billions of atmospheres, and then it comes down. Let's try another one. Let's see. I'll do temperature. So now I'll keep the R mean over R, and we'll generate the graph data. Again, it's working. And I should point out you can do these graphs for any star that you want. Generate the graph. And you can see it's a little weird, but that's how it is. The different elements. Okay. And let's see what the next one is. Volume of shell divided by total volume. In the model that I use here, there are shells. Each element is in its own shell, from hydrogen all the way down to the core with the highest element. So let's generate the graph data. And generate the graph. So here we go. So you can see here, this is, again, the volume of shell divided by the total volume. So obviously the lower elements have a much larger volume than the higher elements, which are close to nil here. All right. And I got one more massive shell over total mass. So let's generate the graph data again. By the way, these other fields here come from, the star table. So you don't have to re-enter them for the graphing. Generate the graph. And there you see it. This is the mass. So obviously the lower elements, even though they have lower atomic number, there's so much more of it that they have higher mass than the ones toward the bottom. Or I should say in the center of the star. Okay, so that's that. Let's go back to density, and then let's use atomic number. while that's working, I can show you, you can save the data to a file. In this case, I'm saving it to test point text, and then generate the graph. So here's the density versus atomic number. Now let's go with the next one, pressure. Generate the graph data. And by the way, these are the graph commands. You can keep this exactly the way it is, but you can change it if you want to. The graph manual is included with the package, but ordinarily you wouldn't have to touch any of the commands here. So here we have pressure versus atomic number. All right, and then temperature. Generate the graph data. Generate the graph. So there's temperature. So obviously it goes up with the element. And let's see, we got volume of shell. Do this one. By the way, the main fissioning element for our sun is lutetium, element number 71. And in this case, it's just, well, the volume really comes down pretty nil for the higher ones. And let's do total mass. Oops, sorry, let's do mass. Generate the graph data. And generate the graph. And, you know, there it is. Pretty small mass, actually, it takes to, in the core, which really provides all the energy. All right, well, I'm going to just put this back. I normally like to see density versus R mean over R, so we'll just run this again, just because I like that particular one the best. That basically shows the, you know, the most basic assumption of the model, a linear density increase from the surface down. So here's close to the surface and then all the way up. All right, now you can look at the data. Let's see, you click here, and then you get this massive table here. Here's the atomic number, atomic mass, mass fraction, R1 over R, R2 over R, volume in cubic centimeters, mass in grams, density, pressure, and temperature. So, pretty amazing stuff here. The R1 and R2 are the radii for the shell limits, so each shell has a limit. You know, so that's what that means right there. So the R1 over R is at the surface, that's 1, and it goes down to here, and then, you know, it zigzags across. All right, so all the data is in here. All right, well, that's enough, so I'm going to hit back. It comes back to here, and I'm going to hit close. All right, so now you know all about the graphs in the Reciprocal System Macrocosmos database. Please study the reciprocal system and prove it for yourself. For the simplest possible treatment, please obtain my work, The Unmysterious Universe. Has all the concepts, many diagrams, drawings. It's the simplest possible way to understand the theory. But if you do want all the mathematics, please obtain my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF file, 711 slides in the PowerPoint file. use the PDF file to search for any term you want. But if you're reading or giving a talk on the reciprocal system, use the slides, of course. Thousands and thousands of equations, tables, graphs, everything is in that. It'll take you months to go through that work. Basically, it represents 50 years of my work with the reciprocal system. Now, once you get done with that, you would get these two database modules. I've already gone over the Macrocosmos database. The Microcosmos database you hear on the right panel. Solid matter properties, including interatomic distance calculations, valence, specific heat, energy and entropy, thermal expansion, compressibility, electrical and magnetic properties, isotopes, and atomic spectra. Liquid vapor and gas matter properties. This program calculates volume and density, specific heat, energy and entropy, viscosity and surface tension, electrical and thermal conductivity. Also includes properties of the cosmic elements, which are inverse to our material elements, right here, and material and cosmic subatomic particles. It also includes photon properties. Has a nice graphing package as well. We'll be getting to this database module very shortly, probably next week. Let's see, there's one thing I should probably do. Let's see. I'm going to go to the help file here. I just want to show you the references. The references are given here. Now, there's 77 of them. So here are Larson's books. Dewey B. Larson was my theoretical physics and theoretical economics mentor. So all of his works are here. And of course, my own mysterious universe and all the papers I've done. I'll scroll down here quickly. All these references, so believe me, there's a whole lot backing this up. And then, of course, all the general references to physics and astrophysics that are out there, like Widener and Sells, Penrose, let's see, Kenneth Lang, Essential Astrophysics, Kenneth Lang, Astrophysical Formulae, Shu, The Physical Universe, Carol Nosley, that's the standard one, An Introduction to Modern Astrophysics, that's the standard textbook these days. Harwood, of course, Condon, SU, Analytical Thermodynamics. There's another paper of mine right there. KVK Nehru is in here. Unsold, and Beshek, The New Cosmos. Here's Merton. He was the editor of the Encyclopedia of Astronomy and Astrophysics, 4 volumes, so that's important. Pasakov and Filipenko, The Cosmos, Astronomy in the New Millennium. It's a good reference. And so there it is, 77 references in here. Pretty amazing stuff. So let's go back. We're back. All right, well, that wraps it up for today. Again, please study the reciprocal system and prove it for yourself. And thanks for your attention.